Hey guys, to go through the next section where we're solving problems, equations, where we have radicals or we might have to take a root. There wasn't really a video that I could find that I liked, so we're going to create it. Now, this is one of the online textbooks that we actually have as a resource. So I'm going to go with their examples and then I might add a couple of footnotes or little comments in order for you to completely understand it fully. So if you wanted to look back and use the book resources, you could use that as well. So let's take a look at this problem here.
Find the indicated real nth roots of A. Part A, n equals 3, A equals negative 216. Part B, n equals 4, A equals 81. Remember, an nth root of A is written as the nth root of A. The nth root of A equals A to the 1/nth power by the definition of a rational exponent. Solution. Part A. Because n equals 3 is odd, and A equals negative 216 is less than 0, negative 216 has one real cube root. Because negative 6 to the third power equals negative 216, you can write the cube root of negative 216 equals negative 6, or negative 216 to the 1/3 power equals negative 6. Part B. Because n equals 4 is even, and A equals 81 is greater than 0, 81 has two real fourth roots. Because 3 to the fourth power equals 81, and negative 3 to the fourth power equals 81, you can write the positive and negative fourth roots of 81 equals positive and negative 3, or positive and negative 81 to the 1/4 power equals positive and negative 3.
Okay. So that was a lot of math jargon, but let me explain what they're saying. They're saying if I want to solve for the real roots, so when they say real roots, they mean like as if we were actually going to solve a problem where we're solving for x and we have to find what actually is available. So for this problem, let's pretend it was like um, I know they're saying that n is the root, but let's pretend it was like n to the third power equals negative 216. In order to solve that, I would take the cube root of both sides. So that's what they're expecting you to do. When they say the n is 3, they're expecting you to take the cube root. If I try to take the cube root of negative 216, if you put that in your calculator, you're going to get an answer. The answer is going to be negative 6. And that's fine and that's great. And you have your answer. But remember when we were doing problems where we had to solve and we had to take the square root? We had to both do the positive and negative version. Do you remember that? So, why am I not doing that for this problem? Well, I'm not doing that for this problem because this happens to be an odd root. Odd roots can be positive or negative. If I multiply something by itself 3 times in this case, I can have, if I do 2 times 2 times 2, I can have a positive number. Let's say I did negative 2 times negative 2 times negative 2. I'm going to get negative 8. I can get a negative answer. So in these problems, I don't have to worry about it. If we have an odd root, I can get either a positive or negative answer, whatever it comes out to be. However, in example B here, that is different. Example B is very similar to what we went over when we were doing those square root problems because it's an even root. So let's pretend this was like n to the fourth power equals 81, and I would have to take the fourth root of both sides. We haven't done that, but you can imagine that we would have to do that if we've had to take the square root, then we would have to take the fourth root. If I take the fourth root of something, it can be both the positive or negative version of that because they're explaining here that it could have been either 3 to the fourth power, which gives me 81, or it could have been negative 3 to the fourth power. That gives me 81, right? 3 times 3 times 3 times 3, that's going to give me 81. Negative 3 times negative 3 times negative 3 times negative 3 gives me 81. So whenever we have an even root, we have to do that whole plus minus thing that we've done before when we were studying quadratics and we had to solve by square roots. Okay, so keep that in mind. So let's take a look at the next example I want to show you guys, which is this one.
Find the real solutions of A, 4x to the fifth power equals 128, and B, the quantity x minus 3 to the fourth power equals 21. Solution. Part A. Write the original equation. 4x to the fifth power equals 128. Divide each side by 4 to obtain x to the fifth power equals 32. Take the fifth root of each side to obtain x equals the fifth root of 32. Simplify. The fifth root of 32 is 2. The solution is x equals 2.
And I'm just going to pause there. We are allowed to write just 2 because it's an odd root. So it's either positive or negative. We don't have to do the whole plus minus thing.
Part B. Write the original equation. The quantity x minus 3 to the fourth power equals 21. Take the fourth root of each side to obtain x minus 3 equals the positive and negative fourth roots of 21.
And now we have to do that with the whole positive negative thing because it's an even root.
Common error. When n is even and a is greater than 0, be sure to consider both the positive and negative nth roots of a. Add 3 to each side to obtain x equals 3 plus or minus the fourth root of 21. Write the solution separately. X equals 3 plus the fourth root of 21, or x equals 3 minus the fourth root of 21. Use a calculator. X is approximately equal to 5 1400ths, or x is approximately equal to 86 hundredths.
So they just kind of
The solutions are
Sorry
x
about
is
that.
approximately equal to 5.
All right, good. They just went ahead and calculated. Let's just say we were going to buy a moldings or something, and it came out to be this number. Well, we're going to actually need to know the inches that we need, so that's why we would actually calculate it. But you guys in class, we discussed that this is good enough. All right, so I have a couple more examples I need to show you. Hold on. We're going to go to this section, and we're going to grab this example. So this is a little bit different. In the previous problem, we had to take the root. We had to take the square root, the cube root, the fourth root, whatever. It's going to show up in the problem. These are different. In these problems we're solving, and we already have a root in there.
Solve A, 2 times the square root of x plus 1 equals 4, and B, the cube root of 2x minus 9 minus 1 equals 2. Solution. Part A. Write the original equation. 2 times the square root of x plus 1 equals 4. Divide each side by 2.
So you want to get the radical sign by itself. So yes, you're going to divide by 2.
The square root of x plus 1 equals 2. Square each side to eliminate the radical. The quantity, the square root of x plus 1 squared, equals 2 squared. Simplify. X plus 1 equals 4. Subtract 1 from each side. X equals 3. The solution is x equals 3. Check whether 2 times the square root of 3 plus 1 equals 4.
So now sometimes in these types of problems, what happens is we actually get answers that do not work. We get extraneous answers is what they are called. So you do have to check your answer. It's not a matter of did you do the work right or wrong. It's literally you can get a wrong answer, an extraneous answer, even if you did your work right.
This equation is equal to 2 times the square root of 4 equals 4, which simplifies to 4 equals 4. So, x equals 3 is a solution. Part B. Write the original equation. The cube root of 2x minus 9 minus 1 equals 2. Add 1 to each side. The cube root of 2x minus 9 equals 3. Cube each side to eliminate the radical. The quantity, the cube root of 2x minus 9 raised to the third power equals 3 to the third power. Simplify. 2x minus 9 equals 27. Add 9 to each side. 2x equals 36. Divide each side by 2. X equals 18. The solution is x equals 18. Check whether the cube root of 2 times 18 minus 9 minus 1 equals 2. This equation is equal to the cube root of 27 minus 1 equals 2, which simplifies to 2 equals 2. So x equals 18 is the solution.
Okay. So we have one more example I want to show you guys. And this is going to have the situation that I was just talking about.
Solve x plus 1 equals the square root of 7x plus
And
15.
it's a little harder.
Solution. Write the original function. X plus 1 equals the square root of 7x plus 15. Square each side. The quantity x plus 1 squared equals the quantity the square root of 7x plus 15 squared. Expand the left side and simplify the right side. X squared plus 2x plus 1 equals 7x plus 15. Write the function in standard form. X squared minus 5x minus 14 equals 0.
We have a quadratic.
Factor.
Yep.
The quantity x minus 7 times the quantity x plus 2 equals 0. Use the zero product property. X minus 7 equals 0, or x plus 2 equals 0. Solve for x. X equals 7, or x equals negative 2. Raising each side of an equation to the same exponent may introduce extraneous solutions. Be sure to check each apparent solution in the original equation. Check whether 7 plus 1 equals the square root of 7 times 7 plus 15. This equation is equal to 8 equals the square root of 64, which simplifies to 8 equals 8. So, x equals 7 is a solution. Check whether negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. This equation is equal to negative 1 equals the square root of 1, which simplifies to negative 1 is not equal to 1. So, x equals negative 2 is an extraneous solution. The apparent solution, x equals negative 2, is extraneous. So, the only solution is x equals 7.
And so, yeah, you would just reject that answer and you would keep the answer that is correct. All right. So, that is your pre-lesson, and hopefully we will go through these problems in class.